Okay, so let's start for today. So today we'll be looking into agentic systems engineering. So in the previous sessions, what we have learned is how RAG works, right? We already saw that what RAG does is basically if the LLM does not have context to your answers, let's say your internal company documentation, right? Via the RAG workflow, what we saw is what we can do is store those documents into a vector database by chunking, embedding them and storing them into a vector database. And then when we ask a question, which the LLM is generally not trained on, what it will do is it will try to look up that vector database to see if I can find the answer or relevant docs to that particular question. It will retrieve the docs, then the LLM will format the answer and pass it to the user, right? So that was the RAG workflow. We saw the architecture and everything around it. What did RAG do? RAG made the model better informed, right? It could answer questions on topics it did not learn during the training, right? So how RAG basically helped us is basically it made the model better informed, like on recent information, on information that it was not trained in, right? It improved the capability of the model. But if we still look at the model, right, the model is basically doing just one thing, which is like it's just reading the text. Or what it means is basically it cannot perform any actions, but it can just give you a response to your question, right? It cannot do anything other than just responding to your question. That is what the current capability of the LLMs is. Like you ask it a question, it can give you an answer. Nothing more than that. If you tell it to perform an action, it cannot perform an action, right? It does not have that capability. It can only do Q&A. You ask a question, it gives you an answer, right? That's it. Till now, we have seen that LLMs only have this capability that they can answer your question. For example, if you ask it, I want to book a flight, right? So it can tell you how it could tell you how to book a flight. It cannot book a flight by itself for you, right? So if you tell it like it says, if you ask it to, hey, book me a flight to New Delhi, right? So it till now we have seen that it has the capability to tell you. It will give you an answer, hey, go to make my trip and do this steps, and this is how you can book a flight. So till now it can do that. But what we want is it right now it cannot do is it will go in and book a flight for you on your behalf. That capability is still not here. So now what we want to do is we want to bring in the capability into the LLMs that they can perform certain actions on the user behalf as well, right? In this session, we'll learn how LLMs can be used to create plans, make decisions, and perform actions in the real world. Okay. So this is, if you see, is a jump that a model that this is a jump wherein we can see that the model that was just talking back to us now is a system that can do things, right? So that is all about agentic systems engineering or agents or agentic AI. So today's agenda basically will be, we'll see what is an AI agent, what is the agentic loop, what is the ReAct design pattern, and when should you use agents and when you should not use the agents. Okay, we'll look around these four things. Okay. So what basically is an AI agent? Okay, we already saw that an LLM can only output tokens in response to a user query. When you ask a question, it can only give you a response or an answer, right? For I'm taking the same example. If I say, let's say a user wants to book a flight, right? So the question would be, book me a flight from Mumbai to New York, right? So the answer could be what? So what the LLM will right now do is it will tell you what dates are you traveling on, what is your budget for the flight tickets, or any other preferences. It will ask you all these questions. So you basically respond with like, let's say I want to travel tomorrow and my budget is between 3,000 to 5,000 rupees and I want a non-stop flight with no hops. Okay. So what it will then do is it will say, okay, great, go to this particular site and book your flights, right? Now, if you go in and tell it that, hey, go and book it, why are you giving me the instructions to book it? Why can't you go and book the flight, right? So what will happen is it will say, I cannot perform actions on your behalf. However, I can find the best flights. So what it will say is like, hey, I don't have the capability to perform any actions, but what I can do is I can give you, I can find information for you. I cannot take any action on your behalf. So this is what the current LLMs will do. Okay, without like if we don't have agents, or this is the limitations with the LLMs right now. We'll see how agents solve this problem, where an LLM can also take an action. Okay. So the model gathered the requirements, it reasoned about the preferences, it even found the website, but the instant the user, I said, right, book the flight, the model hits a wall. It can describe the action, it cannot. So basically, we can see that it can describe the action that go and book in a flight, but it cannot basically take an action on behalf of the user, right? So now what we should do is we should add the capability of tool use. Okay. And we have already seen that models are also trained how to make tool calls, right? During our supervised fine tuning phase, when we were seeing when we were learning supervised fine tuning, we already saw that models can also are also trained how to make a tool call, right? So we already saw an LLM can be trained through fine tuning to invoke functions, right? So let's say if I ask it a question, what is the time, right? What is the current time? So initially it will say, I am sorry, but I am a language model AI. I do not have the capability to access current time or date information. Please check your device for reliable time. So it will give an answer like this if it does not have access to tool calling, right? But after, like, let's say if you train the LLM on tool calling, after that training, what the LLM will do is, if I ask the same question, what is the current time? So what it will do is it will give me a response like this. The time is calendar, and the current parameter is now, is equal to what is the current time. So what basically the model will response is, hey, the time is this. Okay, so this calendar.now is a tool call that will happen on the server where the LLM is hosted, right? So the model, when you ask this question, what is the time, it will give you a response. The time is this. The time is this. Okay, wherein this calendar.now, it's suggesting you to make this function call or tool call and get the current time. So when you make this when you make this call, you will get an answer something like this, 9:35. And then it will also say you can confirm this at, it will give you a link, time.com, and you can feed in the get current time and it can give you the answer, right? So see the response of the model after tool calling. What it does is, in the response itself, it's not giving you the current time. It still does not have the capability to find out the time for you. But what it's telling is, uh, how the time can be found out, right? So it's giving you the answer that the time can be found out by calling this tool called calendar, passing it the parameter now, making this tool call will give you the current time. Okay, LLM is still not trained on giving you the current time, but it's trained on making a tool call. Okay, that if I call this tool, I can get the answer. Okay, so this is how it can answer the questions, or it can make tool calls to answer your questions, right? For example, what is the current time we took, right? So look at what's inside the brackets. Like I said, calendar. Now the model didn't know the time. It learned how to ask for it, or how to make a function call to get the current time. Okay, so the calendar.now response from the model, this response when we get from the model, it's the it's the it's on the server to execute this particular tool call and then get the current time. And then as a user, you will not see this step. You will directly get the time. But model has the capability to call a tool and then give you the time. So model, what it will do is it will give you this answer. The server where the LLM is hosted will call this function and pass it back again to the model. The model will see, I got the time is 9:35. It will format the response from this tool call and give you the answer. So when you type in what is the time, you will not see this intermediary step. This is an intermediary step wherein this response is passed to the server. The server makes this tool call, gives it back to the LLM, and then the LLM will directly give you the current time. Okay. But what I want to focus on is, like, still the LLM still does not have the capability to answer questions which it's not trained on, but it has the capability to use some tools, right? Calendar is one tool, search is another tool, based on which it can give you some answers, right? So during the tool use training, the model learns three things: when it should use a tool, right? So when we train a model, right, during the supervised fine tuning phase, we teach it three things: when to use a tool call, which tool should be used. Like, we give hundreds of examples of tool calls and we tell it, okay, so if the user is asking for search, then use the search tool call. If the user is asking for time, use the calendar tool call, and stuff like that. So it learns when it should use a tool, which tool should be used, and what argument should be passed to the tool to get the correct response. Just like any other training, we train it on like a bunch of tools via which it can understand all these things. That if I have to, if I get a question which I cannot answer but can be done via tool calling, then I should respond with a in a format wherein I can give this particular where I will tell which tool call can you make to get the answer. If the server has this tool defined on themselves, they can call this and get the current answer. Okay, so that's the entire skill of tool use, recognizing the boundary of its own knowledge. Okay, it recognizes that I am not trained on figuring out the current time, right? So it knows that I have this limitation, and then but what I can do is I can produce a well-formed request for an external capability. So making this calendar call is an external capability. I can give a response that you have to call this tool and give me the response what this function is doing, and then I'll format and give back the answer to the user. So what the whole point of tool use is, so we want to focus on that LLMs have one more capability apart from answering user questions, right? It can also basically, it also knows how to make tool calls when it does not knows the answer, right? It has the capability, it is trained already on how to make tool calls. So now we will see how agents leverage this capability of LLM, which is tool calls, to give you answers. Okay, so we'll look into this. So this tool call parts is clear, right? How LLMs are already trained that when they don't have the knowledge, they can check whether I can get the answer from a tool call or not. And where are the tools defined? It's not defined on anywhere on the LLM. It's defined basically on the server which is hosting the LLM. So you have to define which tools I want the LLM to train on, or which tools I have, basically which tools I want my users to provide the capability of. But the LLM just knows how to call a tool which is present on the server. Okay, this will become clear when we go further. So okay, so what does it mean? Does it mean that a fine-tuned agent, a fine-tuned model is an agent, right? So what did I say? That if a model knows how to call a tool, then it can answer questions, right? So does this mean that it's an agent? No. Okay, like models, having fine-tuned models which have the capability of tool using, they are not agents. A tool used, so basically that's not what agents are. A tool used trained LLM can suggest making a tool call or executing a web search. Like I said, an LLM can suggest, right? It can suggest the server that you make this tool call. Okay, LLM does not have the capability to make a tool call. Okay, so a agent is not a fine-tuned LLM, but it is more. It is the system around the LLM. Okay, we'll look into more into this part. This part will become clear as we go ahead. However, like I said, the LLM does not call the API or run the function itself. An LLM needs a system which can execute its instructions and return a response. Okay, an LLM basically needs a system which can execute its instruction and return a response. So something has to read the model's calendar.now. Like I said in this particular example, when the LLM responds with this, that the time is calendar.now, something has to read what is this calendar.now request, right? Actually run this function called calendar function. Okay, feed the result that, let's say this calendar function returns 9:35 a.m. Give this back to the LLM or the model and let the model continue with the new information. Okay, as soon as the model gets this information from the tool call, then it will format the response and give it back to the user. So what basically is an agent? Okay, so let's say if you have a user, a chat application. Okay, basically you have a user fires in query. Basically, when a user fires a query, what it goes to? It goes to a server, right? Then the server has a capability to call a model via APIs, right? And then the model gives a response and it comes back to the server. Okay, and then the server responds back to the user with the whatever answer it got from the LLM. So this server has different capabilities. It can have memory, which is like the chat history of, like when we see chat GPT, right? So we see our history of messages, or like when we are asking questions one by one, right? The history is preserved. That is how when you, let's say if you have asked like 10-15 questions in a session and then you left that session, you came after 5 days and you opened that particular session and asked a follow-up question. So the model has the context of your previous session, what questions you had asked, right? So that is called memory, like storing the conversation between the model and stuff. So the server has the capability, or the server stores those chats. Okay, the LLM does not stores it. Okay, the server has, maybe can store it in Redis or in a database. So that is the memory part of the of an LLM. The server again has the capability to make such some tools called like calendar and web search. And then it also has the capability of RAG, right? Retrieval stores like vector DB. If it does not have answers to certain questions, it can also retrieve information from a vector store. Okay, so see, LLM is just the model part is just over here, right? All the other capabilities, like having the memory or the history of the chats, calling RAG or a vector database to retrieve the context, calling tools, okay, like calendar and web search. These are all capabilities at a server level. So an agent is not this LLM. The LLM or the model is just one part. Okay, all the harness around it. Okay, the memory part, the server. The server is the main part. Its capability to keep the conversations, make the tool calls, retrieval, talk to the vector database and get some results. All these, all the harness or all the capabilities around the LLM. right, is called an agent. Okay. So see, one very important part over here is LLM is sitting over here. The model is just here. It does not have any I mean, it can just give you answers, right? It can just do Q&A. Okay. But we are using the system around it, right? For our example, when I ask what is the current time, right? I'm going back to the same example. What is the current time? So what user will fire this query to the server. Now the server will fire this query to the LLM. Now LLM, what it will do is look back. It will respond in this format. The time is calendar.now, for example. So this response will come back to the server. Now the server will say, what did the LLM say? That the time is calendar.now. So now the server says that now the server has this understanding that the LLM is telling me to make a tool call. Okay. So what is the tool call? Calendar is the tool call and the parameter is now. Think of tool call nothing but as a function. Okay. So now the server will call the calendar call and pass now as the parameter. It will get 9:35 as the answer. Then it will pass the same information to LLM. Okay. Now the LLM will format the whole thing. The current time is this tool call was executed. I got 9:35 a.m. and this blah, blah, blah other information that it has. It will format all this and pass it back again to the server, and the server will respond back to the user that it is. So this whole system around the LLM or the model, which increases the capability of the LLM, or basically this is the system that uses an LLM to plan, make decisions while using tools to execute commands, is called an agent. So this whole system, right, is called an agent. Okay, this is called an agent. The model is not the agent. Many people have this confusion that, hey, what is agent? Is it a model? Is it a model which is more powerful? But the distinction over here to see is LLM is not the agent, but the system that we are building around it, which can enhance the capability of the model, which can help, which can basically, so an agent is something which can help the model to do certain tasks, right? Previously, the model was just answering questions or giving us certain answers to our questions, right? Now it can perform actions on behalf of us, like booking tickets, searching information on the web, or any other action. The action could be anything. Basically, what an agent means is if you want the LLM to do some task on your behalf, that is called an agent. So the agent is the framework around the LLM. Okay, we'll look into this more via examples. But if you want to understand it via an analogy, LLM alone is nothing. But think of it as a brain that can only talk. Okay. So LLM alone is nothing, but it's a brain that can only talk. You give it a question, it can give you an answer. LLM plus tools, okay, a brain that knows it should use a tool, right? So brain previously know that it can only give answers. Now the LLM plus tools is the brain knows that apart from giving answers, I can call certain tools also. And the agent, what is agent? Brains plus brain giving the instruction to the hands and a loop that connects them. Okay. So what is an agent? I have an LLM. I have certain tools defined which I can use. Agent is a basically a, you can think of it as a program that continuously in a loop talks to the LLM to get certain tasks done. Okay. So an LLM is the brain. Tools are the hands. Okay. Tools, think of it like if I take the analogy of a human body, right? The LLM is just the brain. Tools are what? Hands. And agent is the nervous system. Okay. That lets the brain drive the hands, look at the result and decide what to do next. Okay. So the LLM is just the brain. We have the hands and everything. So agent is what? The telling the talking to the brain and doing certain actions. Okay. So that is what you can understand from a human analogy point of view. Okay. So now there is another important concept which is called the agentic loop, right? Like I said, this whole interaction, right? Previously, what we had seen is you fire a question to the LLM, it gives you back the answer, right? This is just one flow. You give a question and it gives you an answer in one shot. Okay. So in RAG, what we saw, we'll see what an agentic loop is now. This is also a very famous term, or like it's you will see this as a buzzword used across at many places in LinkedIn or different other places. Okay. So what is actually an agentic loop? In RAG, the flow. Okay. Just give me 1 second. Use this. Okay. So in RAG, the just give me 1 second. So yeah, basically we were talking about the agentic loop. In RAG, the flow was linear and ran exactly once, right? Like I said, in RAG, what was happening? We had a query. Basically, we pass that query to LLM. LLM sees that I don't know the answer to this question, but I can retrieve context right from a vector database. I pass that context into a prompt, and then the LLM answers based on it, right? It was a one-shot thing. Okay. Basically, the whole flow was linear. I post in a question, and the LLM figures out that I need to look this information from a vector database. I get that information. The LLM then formats the answer and gives you back the answer. There was no thinking or there was no to and fro. You give the question, the LLM answers, right? But what an agent does differently is an agent is different because it loops, right? The model takes an action, sees the result, and then decides its next action based on that result, right? Now, instead of just one shot, you give a question and it gives back an answer. What the agent does is whenever the LLM produces an answer, right? So it sees the result, then actually decides based on the result what is the next action it can take, or it can give you, or it can directly answer from that. So there is a loop going on between the LLM and the system, wherein the agent thinks based on the LLM's response and then basically responds back to the user. It keeps going on until the task is actually finished, not until it has produced one paragraph of text, right? In RAG, you give a question, one paragraph of text comes up, finish, over, right? But here, the agentic loop is different. You ask in a question, the LLM gives you an answer. Okay, then we reason around it whether the answer is right or wrong, whether do you need more information or not, whether there are different steps involved or not. Right. So it will decide on all those parts. A loop will be going on between the system and the LLM, and then it gives the answer. So that part is called agentic loop. So, but why does this loop? Why is this loop needed at all? Because real tasks have steps that depend on each other. Okay. So let's say if I have to book a flight, right? So booking a flight is not simple. It's a multi-step process, right? First, what will you do? You will search the flights. If you have to go to a particular destination at a particular date, you will see what are the flights available. Then you will see the prices. Then you pick one based on your like hops or let's say the time or let's say the price, right? You choose based on various different factors. Then you check the calendar also, what time do I want to go, and then you actually go in and make a or reserve a seat, right? So see, booking a flight is a multi-step process, right? So that is where an agent comes in, where you perform an action based on certain steps. It's not a one-shot thing. So that is the agentic loop. Okay. So, like I said, right, what is happening is, like, let's take an example, book me a flight to New Delhi tomorrow, right? So in pass one, what happens, right? First, I will have this query, book me a flight to New Delhi. Okay, look at this system. We'll look at this part, all of this together. We are looking at agentic loop, right? Let's say we have an agent which can book flights for you. So what is the agentic loop and how does the agent works along with the LLM? What is the whole system? We'll look at this via this example, right? So let's say my goal is book me a flight to New Delhi, right? So the user is sitting over here. He will have this query, book me a flight to New Delhi tomorrow. It will go to the server and the server will pass this information to the LLM that, hey, book me a flight to New Delhi tomorrow, right? So till this question, this goal came to the LLM. Now in pass one, what happens is LLM, it will say, so what will happen is when the user query is given, right? When we pass to the LLM, we also pass the information that the server has the capability of these tool calls also, right? Search flight is one capability or one function that is defined at the server. Book flight is another capability which is defined at the server. These tools, the server has access to it. So when I pass this query, book me a flight to New Delhi for tomorrow, right? The user query came into the server and the server passed it to the LLM along with it also defined, okay, like when it passed the query to the LLM, right? It passed the information that, hey, I have access to these tool calls, okay, which is search flight and book flight, right? So now when the LLM sees this query, book me a flight to New Delhi tomorrow, and it sees that server has this capability of search flight and book flight, what it does is the LLM responds back to the server saying that, hey, use this function according to the user query. The user wants to book a flight to New Delhi tomorrow, right? So you have a capability called search flight. Call this capability search flight with the parameters New Delhi and tomorrow, right? So the LLM will respond, okay, with this particular response back to the server. So now the response will come back to the server. Now the server will see, hey, LLM is telling me to call this function search flights with parameters New Delhi and tomorrow. So the server will execute this action, which is this tool called which is search flight. It will pass in the parameter New Delhi and tomorrow over here, and then it will get some information from this API call, right? Flight 1, flight 2, flight 3, along with the prices like 3,200, 5,000, 6,000, something like this. See, the server is making this tool call. Okay, this is just a function call. Now it got this call. Now it will again pass this information to the LLM with all this flight information, flight 1, flight 2, flight 3. Now the LLM will do the reasoning. Hey, which one is the cheapest flight? Flight 1 was 3,000, flight 2 was 4,000, flight 3 was 5,000, right? So it will see, okay, the user had asked me for the cheapest flight. So it will say, it will figure this out. Then again, it will pass the information back to the server. It will say, go in, I found the cheapest flight, I found the cheapest flight, go in, and I saw you also have a capability of book flight. Go in and call the book flight function with the cheapest flight. Like let's say for flight 1, 3,000. Okay, so it will go back to the server. Now the server will make the tool call or the function call, which is defined on the server, to book a flight with the cheapest call. So this is how, and now when this booking is done, right, it will get a response that flight booked or something. It will take this information and pass to the LLM. So the LLM will format the response that, okay, if let's say this book flight had a JSON data, right? That, hey, your flight is on this date, this particular time. These are your, this is your luggage capacity and all those. You got the JSON data, right? By calling this function call. Now the LLM, what it will do is, once the book flight response is passed to the LLM, it will format it in a human readable form and then pass again back to the server, and then the server will respond back to the user, right? So did you see what an agent? So this part is called an agent, right? What we are doing is, we are not just calling LLM in one shot, but we keep an interaction between the server and the LLM in a loop until and unless we get the response, right? What we are doing is, in a loop, we are talking between the server and the LLM, wherein there was a goal or a task which the user wanted to do. Server is talking to the LLM that this is the goal. It's doing multi-step reasoning in a loop that, hey, these are the flights that I have. Then the LLM reasons that this is the cheapest flight. It gives back to the server that, hey, I found out the cheapest flight, book that flight. The server has the tool call of booking flight. So it will make it will call this function, return the JSON data to the LLM. Then the LLM formats that in a human friendly format and returns it back to the server, and then the server responds back to the user. So this whole part is called, so this part, okay, the whole system is, like I said, is called an agent, wherein now the LLM is no more just giving the response to the user, but it's actually also doing tasks on behalf of the user, like booking a flight. And the agentic loop is the interaction going on between the server and the LLM in a loop. Okay. So I hope via this example, it's very clear what an agent does, right? Or how is it different from LLM? LLM can just answer some questions based on user, but agents are more than that. It's an LLM performing a task for the user. Okay, so this is what an LLM is. Now, one thing which can come into your mind is, what is the exit condition of this loop, right? We are interacting between the server and the LLM, but how do we know when to exit this loop, right? So the exit condition of the loop is, as long as the LLM keeps asking for tool calls, right? The loop keeps spinning. The moment no more tool calls are required, you have your answer, right? So in this particular example, if you see, when you pass in the first query to the LLM, the user wants to book a flight from New Delhi to book a flight for New Delhi tomorrow, right? So when you pass this information along with the tools you have, the LLM told you, hey, call this function search flight, right? Then the control came back to the server. The server executed this search flight function and gave the results back to the LLM, right? Now the LLM told, hey, call this tool that you have booked flight with these parameters, the cheapest flight parameter, like flight 1. So now again, the LLM sent back the response to the server via API or something, and the server performed the action of booking the flight with blah, blah parameters, whatever the LLM said. So now it booked now after calling this function, it got a response, it passed to the LLM. Now the LLM just gives you back the answer, right? It will not tell you further to call any tools call, because it feels that it has achieved the task. No more tool calling is required. So that is what the exit of this loop is. Like when the LLM no more requires a tool call, that's the exit condition of this loop. And then you can respond back to the user, right? So this is the exit criteria of the loop. Now, one more thing which is commonly used around this agentic loop or agents, there's a common design pattern that is used, which is called the ReAct design pattern. So the above loop, what it does is, basically, the above loop works, whatever we saw, right? But it has a weakness. The model jumps straight from the goal to the call of this tool with no visible reasoning, right? So what is happening over here? When a query came in, right, you pass that, it had a set of tools, right? So it passed the tools along with the user question to the LLM, right? There was no reasoning or any step, and the LLM basically takes a shot into which tool should be called. Now, let's say in my tool set, there are multiple tools which can be similar, right? Which is like book flight in Indigo, book flight in, let's say, Emirates, or let's say book flight in Air India, right? Some similar function calls can be there, right? So in that case, what can happen is, like, if the functions are very close by, right? And if the LLM is just taking a shot at it without doing some reasoning, I mean, I know LLMs have some inbuilt reasoning capability, but React design pattern, what it does is, it via prompts, it tells the LLM to reason about like what action it's performing or which tool does it wants to call. So this is a that is called the React design pattern. Okay. So what the aim of the React design pattern is, when it tells the model that so basically it improves the model. So when the model, so what will happen is, when you don't use the React design pattern, if a model picks the wrong tool, right, you have no idea why the model is picking this tool call, and the reasoning will become very hard. But with React design pattern, you add an extra step in the prompt saying that you have to reason about, right? React is reasoning plus acting. So when you do anything or when you perform any action, you have to reason through it. Okay. So the model, what happens basically when we use this React design pattern is, the model produces a thought, then takes an action. The system runs the action and returns the observation. The model then produces the next thought and the action, right? So it's just basically the same thing itself, but it's just a fancy word of adding an extra prompt so that the LLM does better reasoning around it. Okay. So let's see one example. It will become much more clear. React in action, what happens is, let's say, what's the weather in the city I am flying to tomorrow, right? So you had your initial query that book me a flight. Now you pass in the question, what in another session, what's the weather in the city I am flying to tomorrow, right? So the LLM first produces a thought. Okay. What thought it has? I don't know which city the user is flying to. Maybe I should look up their booking first, right? So it will say, then it will produce an action. Hey server, get me this get booking, call this get booking function, right? So now the server will call this function and provide this information. Destination is New Delhi, date is this thing, right? So in this loop over here, right, that we saw, LLM produced a thought, it produced an action and passed it on to the server that do this action. Server responded back with the action that destination is New Delhi via looking at the current booking of the user, New Delhi, and the date is this. Then again, when the control comes back to the LLM, again it will think the destination is New Delhi and the date is tomorrow. Now I need a weather forecast for New Delhi on that date, right? So again, it will produce an action. So first it thought or reasoned about it, right? Now again, it produced an action that I have to call this particular function called get weather. I have to pass the city, sorry, not New York, New Delhi, and the date is this particular date. Now again, it will pass on this particular action to the server. Then the server will call this particular tool called get weather, and it will return this information. Temperature is 12 degree and the condition is rainy. So now it will give back this information to the LLM. Now the LLM will again, based on this, all these above information, again it will think that I now have everything I need to answer to the user. No more tools is required, right? So it will again produce an action, finish. I don't need any tool calls. Just respond with this. It will be about 12 degree and raining in New Delhi. So now when server gets this response, it will just give this response to the user. So React pattern is nothing but adding just an extra prompt when a question is passed to the LLM, that reason through your actions, right? Instead of giving the actions right away, reason through it step by step so that you can come to a correct conclusion. So the only difference between React and the raw loop is React pattern makes the model more reliable. Okay. So now we know what the agentic loop is, what an agent is. Basically adding capability to take actions in an LLM is just an agent, right? Agent is just a fancy word. Basically, it just means that an LLM can take certain actions. That is what an agent can do, right? So now we will look at how all of this works, right? I will show you via one program, but let me just give you a brief overview. Like how should we, like when we are at a server level, right? I already told you about this thing that we have to define the tools, right? Like the server has to define these tools, search flight, book flight, right? All these functions should be defined at a server level. And then what we will do, right, whenever this initial query is fired, we will let the LLM know that server has these capabilities via a prompt. Okay. So we are looking into this part. that how do we pass this, how should we define the tools, and how should we pass this information to the LLM in the initial query. Okay, how do we pass this information? So defining tools, what the actual LLM receives. We keep saying that the LLM asks for a tool call, but how does it know which tools exist in the first place on the server? So we have to define them. A tool definition is a JSON schema describing the tool's name, what it does, and the argument it accepts. Okay, so look at this again at this workflow. So when we are at a server, what I will do is, first and foremost, these functions I will define. Okay, so I will create a function called search flight. Okay, I will create a function called book flight. I will create a function called calendar call. Okay, I will create a function called I will search. Right, I will define all these functions in my server code. Right, this is the front end code, the backend from the front end from where the user fires the query. It reaches the server. Like we define normal functions, I will define these functions at the server level. Okay, these 4 functions I have defined, like using a function definition or something, and I will not pass these functions to the LLM, but I will pass the JSON schema to the LLM so that the LLM knows that these capabilities are available to the at the server level. So how does the JSON schema look like? It will basically have a name, like book flight is my function, right? So this is how the JSON schema, we are not passing the function, but we are passing a schema to the LLM that, hey, these are the capabilities present at a server level. This is the JSON schema for book flight function. It will have a name called book flight. It will have a description. Call this to execute a booking only after a flight ID and passenger info are confirmed. What are the parameters to this function? Type is object. Properties are flight ID, passenger name, passport number, and other stuff like this. Okay. So see over here, what I'm doing is whatever function I have defined at a server level, I am passing its description and the parameter it takes to the LLM. Okay. And in all my calls, right, whenever this interaction or the to and fro between the server and the LLM happens, in every call, in every API call to the model, in the prompt, we will stuff this information that the server has these capabilities. So the name, description, and the input parameters of every tool must be defined in this schema. The model reads only this. It never sees your actual Python code, right? Functions I will define in my Python code, but the model never sees the Python code. It will only see this JSON schema of all the functions that I have defined, right? So because we are passing a prompt in a simple English language, right? So we will pass this information of the function, what name, description, and parameters it takes along with the prompt. Okay. So the description, so see, one very important part is when you pass this description, right? The description is what is used by the model to decide which tool to call, right? I have five tools calls available on the server. I have given description of each tool call, right? Function one, for example, let's say function one has this description. Okay, I am passing this to the model. Function two has this description, right? Function three has this particular description, right? So now what the model does is it does reasoning which function to call. So if I don't give a proper description or proper parameters when in the prompt, when I pass that information to the model, it can call wrong functions, right? If it does not have the current context. So it's very necessary that when you are creating this JSON schema for all the functions that you have at a server level, you pass in the description very accurately. There are some there are some tips which you should always take into consideration while defining this JSON schema or the function call. What does the function do? In the description, you should cover these parts, right? What does the function do? When should it be used, right? What exactly is the parameter, right? What the tool returns, and some examples, right? So what I'm trying to say is when you are creating the description of the function, right? You should include what is it exactly doing, when it should be used, right? What are the trigger conditions? What do each of the parameters mean? What does it return? And give few examples when you are creating the description. So see the advantage if you do it via this, right? LLM, it does not call the function, right? It just returns back to the server that, hey, you should make this particular tool call, right? So until and unless you give the functions description currently, how will the LLM is just doing the reasoning part, right? So if the description and all the things are not correct, how will it reason correctly that which tool has to be called, right? So in order that the LLM does the reasoning around which tool call should be done, we should describe the JSON correctly, right? So this is what this was about. So what we have seen till now, I'll just revise the whole concept so that it's very, very clear. We have a user, right? So what is an agent? what does an agent do? LLMs just like previously, LLMs could just talk, they could answer, right? They could do a Q&A. If you have a question, it can just answer. What agents added the capability to LLM is performing actions, right? Performing actions. How to perform actions is via tools call, right? We already tools call, right? We already know that LLM has the capability or it's trained during SFT supervised fine tuning that in its response, it can tell, it can reason out that when to make tool calls, right? It can just reason, it can tell you which tool to call, but but it cannot do the actual calling, right? And we saw that what do we do if we have a user query and the user query from the front end goes to the backend server where it's hosted, right? So in the server, when I'm defining the server, just like I define my APIs, I will define the tool calls like search flight, book flight, search flight, book flight, calendar, search, Google, something like that. We'll define all these functions. They are nothing but functions. We define these functions at the server, and then when we pass the user query, basically we pass it in a prompt, right? We have seen that part. So in that prompt itself, we will include in the JSON information the description of all these functions, and this will be passed to the LLM. Now the LLM, what it does is it will reason around that based on the user query, if I have to perform an action, if the user wants to perform an action, I should call this particular function on the server. So the LLM still just does the reasoning, which tool should I call? And then this interaction between the server and the LLM goes in a loop, right? To achieve a particular goal, right? This goes to and fro between the LLM and the server, and the particular goal is achieved, right? So this whole system is called agents, right? So agents are nothing but the capability in LLMs to perform certain actions. Okay. So now let's do, we know the concepts. Now let's look at it live via an example that how does it work end to end. Okay. So I will quickly share my screen and we will walk through one example that how does it work end to end. Okay. So again, I have a notebook where I will cover, like we'll build an agent, whatever we have talked about, and we'll go through the example line by line to see how it works end to end. So you can see what we'll do is we'll build an agent from scratch, hands-on. We'll build a tiny travel agent with no frameworks, right? We'll not use any frameworks right now, just OpenAI SDK so that I can make an LLM call and then plain Python so that you can see all the moving parts and what is the agentic loop of thinking, acting, observing, and then repeat. We saw the ReAct loop, right? Which is reasoning and then acting, right? So think, act, observe, and repeat until the goal is achieved. So we'll see all this in action end to end, right? So for this, first and foremost, what I'm doing is pip is a Python package manager. I'll install this Open API SDK. Okay. So this step executed, this is installed. Now, if I want to use this SDK, obviously I need an API key. So I'm just setting up the API key over here. Then let's create, we pass the API key to the OpenAI so that the client is ready. Now see in this part, this code is running in my server. Okay. So think of it as a Python server, right? So over here itself, I am defining the functions, right? Going back to the diagram, I told you, right? We will only define the functions which we have, right? Let me go back over here. So we looked at this part, right? So at the server level itself, we will define the tools and everything like search flight and book flight. This is defined at the server level. So see over here, we are defining the tools, right? Right now they are dummy functions, but in your actual, when you develop actual agents, you have to define the functions, whatever you want the agent to do, right? So you have to define those functions at your server level. Like get booking and get weather information are two functions which I'm defining at the server level. Simple, they are just as normal as simple API calls, right? Get weather function takes two parameter, which is city and the date. And right now, what I have done is I have just created a fake DB that return this temperature and this, right? But over here, you'll have to define the actual API call of whatever task you want to do, right? So let's execute this. This is done. Now, what we will do is, I told you in the last step, right? What we will do is after I have defined the schema, after I have defined the tools, right? From the server, when I pass in this question, book me a flight, right? I have to pass the information of the tools, right? I have to pass this in the JSON format, like we looked at over here, right? This JSON format that we discussed over here. So see over here how I had these two tools, right? So I am passing the JSON schema over here for these two tools. What I'm doing is I am defining a variable called tool schema. I am telling it's a function call. What does the function do? Get booking, get the current flight booking, and destination when the destination and date is provided, and parameters are given that it's just an object. This is one function, and I'm defining in the tool schema another function which is get weather. What does the get weather function do? Gets the weather forecast for a city on a date, right? And the parameter it takes, it's an object. It can have city and date as the parameter, and these two are required parameters, right? See, when I pass the user query to the LLM, right? I will not pass these functions. I will pass this tool scheme. Okay, we'll look at this. So this is really important. Now see the agentic loop starts, right? This is the part that turns an LLM into an agent. It runs, think, act, and observe whatever we saw, right? ReAct loop, reasoning and then acting, and over and over again until the model stops asking for tools, right? The one rule: did the LLM ask for the tool? There is only one rule. If the LLM asks that run this tool, then okay, we will call that tool and then give back the result to the LLM, right? So first, let's show you this part. The goal is what? So I have a question. What's the weather in the city I'm flying to, right? I have defined already these dummy functions, right? Which can get the booking information and which can get the weather information. And I'm passing this tools. I'll pass this tool schema to the model, right? So this is my question, right? I'm calling this a run agent and I'm passing my goal to the agent, right? So now see how this function works. In the run agent, I take two things. What is my goal? Basically, I just want to pass the goal. And there is one additional parameter, which is like, obviously, this is a safety net kind of. Like when I'm running the agent, right? We said that the agent can run in loop, basically. So what we want to do is we want to define how much, like let's say the agent can go in an infinite loop also, right? And the LLM calls are expensive. So the tokens can cost us a lot of money. So as a safety net, what we say is after, let's say 100 steps, if you are still not able to get to the answer, stop, right? So that is what the max step defines. That maximum, here it is very low, but in actual production environment, it could be like, you have to estimate this, that the agent can, if the agent cannot get answers after looping, after 5 steps or 10 steps, right, then it should stop so that it does not go into an infinite loop, right? So this is what run agent does. It takes the user goal and what is the stop step, or like after this step, it should stop. Then what do? We actually pass the messages, right? We have already seen that we pass these messages to the OpenAI model, right? Over here, this is the model. Which model do we want to call and what are the messages, right? Basically in a chat application, whatever we type in, that are the messages that we pass to the model via an API call, right? So over in the messages, this is the first system prompt. We have already discussed that in a system prompt, what we basically do is we always say what the model is, right? We define what the model does, right? So here in the system prompt, we are just telling the model that you are a helpful travel assistant. We are telling the model what is the persona that the model is. It is a helpful assistant, or it could be something else. It could be a tutor. It could be something else, right? Whatever you want the model to do, you just pass it in the system prompt. You are a helpful travel assistant. Use tools. See, this part is important. Use tools when you need real data, right? And in the second message, what do? We pass the user goal, right? So system prompt covers what is the system doing, or what the model is, how should the model behave currently. And the second message is the actual user message, which we pass over here. What's the weather in the city I am flying to tomorrow, right? So it gives this. Now see over here, now we are, if it would have been a RAG workflow, there would not have been this for loop, right? So now see over here, this is the agentic loop or the for loop, wherein I am just using this range query that go in a loop, but after these many steps, just break out of it, because it means that after these many steps, if you don't get an answer, you are basically going into an infinite loop. Now in this for loop, right, this is called the agentic loop. We are calling the OpenAI model, wherein I pass the model, which model I want to call, what are the messages that I have, and what are the tools, right, that the server has capability to, right? So see, I'm passing the tool schemas, right? Like I had already said, I have defined the tool schemas. I'm not actually passing the functions. I'm passing the tool schema, right? See, in my query to the model, I'm passing that server has information to these tools, right? And then I'm waiting for a response for the user, right? Now what I do is over here when the response from the user comes back, right? Response.choices.messages. What I'm doing is I want to remember like if there is a to and fro communication between the model and the server, right? I want to remember all the messages because agentic loop, like we saw, right? It's not a one-step thing. It will happen in multi-steps. So I want to keep a track of all the messages that are going between the server and the model, right? So I'm appending the messages to this messages array, right? Now, like I said, right, the exit condition of the tool will be, I am looking at the response of the user, and in the user response, there is one parameter which is called, which says which the LLM response is if it wants to make a tool call or not, right? We'll print this and we'll also see. But right now, see, we are seeing that if in the response from the LLM, right, if it's not a tool call, right, you have to just return, because like we had discussed, right, if it's not a tool call means the agent has the answer, right? Over here we saw this part, right? What is the exit condition of the loop? As long as the LLM keeps asking for tools, the loop keeps spinning. The moment it stops asking, you have your answer, which means that as soon as the LLM does not have a tool call, it has the answer mostly, right? So we are saying that if there are no more tool calls, then the loop has the answer, exit from the loop, right? But if in the message, or if in the user's response message, if there are any tool calls, right, there can be one or multiple tool calls. If there is a tool call, I am looping over those tool calls. I am extracting the function name from them, right? I want the arguments. The LLM will give you that call this particular tool call with this particular arguments. Okay. So I'm printing that what is the action, what is the name, which is the tool call the LLM is suggesting that you should make, and what is the arguments you should print, right? I'm printing these two, right? Over here, what is happening? After I made a call to the LLM, right? The LLM is suggesting, hey, server, do these tool calls. They are defined. You gave me some information that you have these tools available in your belt. So you make these tool calls and give me back the response, right? So it's telling that, okay, and the LLM responded that, hey, make these tool calls. So it will make, now see, once I got the name and the argument of the function to the call, right? So what I will do is I will actually make the call to that particular function, right? So I am, see, available tools. What is available tools? Available tools is over here, right? Where I was passing this function. So in Python, what this is a way by which I will basically call that particular function dynamically, right? And I will get the result. So the LLM told me, hey, call this tool, call these, make these tool calls and give me the result, right? So I will keep on doing that until and unless until and unless I get a response. And once I get a response, I will stop and respond back to the user, right? So this part is clear. Let me execute this. And then let's go into this part. See, goal was what's the weather in the city I'm flying to tomorrow. So if you see, step 0 was the LLM suggested make an action, right? Over here, right? It gave one tool call, right? What is the action? Call this get booking function, which is defined at the server. So now what I will do is I will call this get booking function, which is defined at the server. What will it return? New York and date this, right? So what was the user query? What's the weather in what I am flying tomorrow, right? So it told, first step LLM told me to perform this action, get booking, right? So it gave me New York and this. Now the LLM, see, it observed that the destination is New York and the date is this, right? Again, we'll pass this information to the LLM. Now again, the LLM will, this was step 0. Now at step 1, LLM will, after observing this, that the destination is New York and date is this, LLM will again tell me, hey, server, go and call, you also have this get weather, right? Go in, call this get weather function, which you have already defined at your level, this get weather, and uh, pass in that particular function, city, New York, and date as this, right? So, and then what will happen is it will tell the server to execute this action. So the context will return to the server, the control will return to the server will execute this particular call, and see, over here, I'm just returning this data, right? That return for New York, the temperature is 12 and the condition is rainy, right? So the server will execute this call and pass it on to the LLM, right? So so it will get the JSON response, temperature is 12-degree, condition is rainy. Now what LLM will do is, based on all of this, right, it will format the response that the weather is New York, the weather in New York tomorrow, June 21, 2006 is expected to be a rainy with a temperature of 12 degrees Celsius. So it responds, or it gives the final answer to us, right? So this is what a weather agent could look like. What it's doing, it's agents are just fancy terms, but what we are doing is basically we are calling LLMs in a loop, and we are asking the LLMs to call certain tools which are defined at the server level and reason through them. So agents are nothing but LLMs with hands or the capability to perform certain actions. Okay, so this is what a simple agent can look like. But like I said, right, agents could be anything complex, right? Whatever function you want to automate, you can define those functions over here, pass the response to those functions in the loop to the LLM. The LLM does the reasoning part, that I have these capabilities, I can do this thing, and gives you back. But the server actually does the calling and everything. So this was an overall workflow of the agents. I hope it makes clear what an agent is. An agent is just nothing but an LLM doing some task rather than just asking plain questions, or rather than just giving plain answers. We added an capability to LLMs to perform certain tasks as well. Okay, so that is what agents is. So for today, we'll keep it till here. Tomorrow, we can look at multi-agent framework or some more examples of agents. Thank you.